I'm Nictarios Georgiolas from BT, and I'm here to talk in the next few minutes just to give you a brief overview of our catalyst for TMForum Live 2017 under the name Smart City on the Edge. It's the third iteration of a catalyst we started about 3 years ago. It's building on the use case of MK Smart, Milton Keynes. It all started 3 years ago when Milton Keynes, one of the most modern cities in the UK, wanted to understand, been driven by loads of challenge around growth, population growth, economical growth. They were trying to see how they could optimize the usage of their resources in order to control the investment for catering for this growth. So they wanted to go the smart city way to understand where they can draw more efficiencies by optimizing the usage of their resources. So we worked with them for 3 years, trying to help them understand where these efficiencies can be drawn from. BT developed the data hub approach, which you see on the left-hand side of the slide. So sensors come in, collecting data. The data come into the data hub, and then they can be taken out of the data hub from the top to drive innovative application development. And also on the right-hand side is the technical ability to enable ecosystems and marketplaces where data can be monetized and become a tradable commodity. So data providers can sell their data, data consumers can buy the data, and therefore we can support data marketplaces and beyond. Like services can also be traded, applications can also be traded. Both of those capabilities sit on the cloud, and that was the scene in the past couple of years. We also did some SLAs for customer applications on the cloud last year in the service level management for smart city ecosystems catalyst. This year though, we go the extra mile where we're trying to bring some of those capabilities sitting on the cloud closer to the edge where the devices and the data, the raw data is collected, sensors and gateways in the field. So we're trying to, at the top we see an example of video camera or sensors collecting the data, and in the case of video cameras, recording traffic, for instance, flows in the streets. They collect very massive amounts of video streams that in the first approach of data hub sitting in the cloud, they would send the streams over the network, clog up the network, and we would expect applications to pick up the video streams from the data hub in the cloud for further analytics. If you go to the edge, then you push this application, analytical applications to the edge, sit on the gateways, receive the video streams straight from the camera, do the analytics locally. In the example of the slide, we see a car count application. So the application analyzes a stream, counts the car per minute in that street, and then passes back only the number, a few bytes of information, and therefore we're saving speed, velocity, which means performance of the applications. We cut out the latency of the network, and we're also able to cut down the volume of information that goes to the network by pushing information on the edge. Here's the high-level architecture. This is possible now because the gateways we get are sort of general-purpose devices, obviously restrained devices in terms of resources, but yet again, devices capable of running applications on the edge. Here we see the high-level architecture of the environment we have built actually for the catalyst. We have car counter applications running on the edge, and we have a police scenario where the police want to go after some criminals who try to escape in the city in a car. The police know the number plate, so on demand they deploy a number plate recognition application on the edge, the gateways that receive the camera feeds. So that application can recognize the car when it sees it in the street, and therefore a police control room where it runs the dashboard, it can see exactly the coordinates of the car in the city, and therefore they can actuate locally. For instance, they can do traffic lights, switch them to red, therefore they can create congestion in the city, go capture the bad guys. It's all happening in the edge, and we can only pass this information, short information, in the dashboard that a police control room sees in the back. Next to the applications, we've got some edge management capabilities in the form of IoT storage, so we can get those data coming out of the applications and be stored locally. We've got usage collection. Those applications are deployed there and are billable entities, so we need to know how much they've been used and how many resources of the device they have been using. Therefore, we can bill for them. You got virtual network controller. There's a physical connectivity of the device, the gateway on the network, but we have ability to allocate certain network capacity to each container, and therefore we're able through a network QoS API programmatically to set up or even change the network capacity of each container. And finally, we have we call it IoT router application, which allows the data to be streamed either to the data hub, it is data hub in the cloud, or another IoT platform sitting on the cloud like AWS or Azure, which is a third party's choice of IoT app in the cloud. This shows a bit more detail about the Catalyst high-level architecture. We've got plenty of devices like that. We've got a catalog of edge applications we can deploy. In our example, we have car count application, number plate recognition application. The thing you also see here, the orchestration happening there is happening from CloudSoft, AMP, application management platform, which can control the deployment of application containers on the gateway devices. They can also orchestrate the network resources that each container will consume, and it also allows us to control the interactions with the cloud in terms of billing, in terms of service management as well. Another key element here that comes out of this slide is that the gateways can talk to each other as well. So we have scenarios around application placement. If it comes the case where, for instance, the number plate recognition application wants to run on the gateway on the left, but that gateway device is overused by other applications, we will choose to place it on another nearby gateway, which has available resources to use, but still again consume the data feeds that's coming into the first target gateway. So that shows us that we can actually join together distinct edge devices, gateways, with general purpose resources at the edge as a common unified resource pool and run applications at the edge, like a cloud that we push to the edge. In this slide here, we show you new types of SLAs that we have developed, which are edge related. Very quickly, there's resource usage-based SLAs, where we allow to define how much maximum resources can be used by each container. We classify them in bronze, silver, gold, and we can say a certain container can use maximum gold service for CPU, for instance, or silver service of storage, bronze service of RAM, or any bundle, any combination of those, and that way we can cap the resource utilization of the container. We can also allocate network QoS to each container as a low, medium, high bandwidth, but we can also, as a customer, can elastically allow the application to define configuration for the application container so that the system orchestrates and bumps up the bandwidth of the application container if the demand of the application for network requires to go higher. If it doesn't require higher bandwidth, the system automatically will orchestrate the network bandwidth lower, and therefore charge lower. So we can also have charging options based on the location of the devices. If you are in premium locations within the city, you charge more. If it's suburban areas, you charge less. And we also have class of service defined based on the specification of the gateways. If it's a premium, high-spec device, you can charge more. If it's a basic device, you charge less. These edge computing capabilities in the data hub are horizontal capabilities, and in the Catalyst we have scenarios to support different verticals on top of them. So I give you examples of smart city use cases, but we also have scenarios around the smart grid application coming from Agile Fractal Grid. Here you also see the partners in the Catalyst. It's important to note that this year we have an extra sponsor city, Dublin City Council, who are interested to use the same scenarios in the same capabilities for scenarios that have in their own city. Here we show how we're using the different TMF assets. Noteworthy here is to mention that we have contributed loads of the capabilities of the Data Hub and Edge devices back into the Citizen Platform architecture, and there's 3 reports we're currently working on as a result of this group. And here we show an example of how Dublin actually, use cases coming out of Dublin that they want to see, some of these capabilities and architecture concepts, solving some of their problems, which is all about traffic management, car crash detection, and also monitoring of traffic flows in the city.